Okay. Hello, everyone. Let's see here. I think that's good. I think that's good. I think this is all good. So, hopefully there are people who can actually hear me now. Maybe even be able to see me. Well, no. Hopefully no one can see me. And that was still playing in the background. Awesome. Okay. I think all my sound is off now so that people can actually hear me. So, what are we doing today? As you may or may not know, last weekend was OCTF, Zero CTF. Basically, it was a CTF put on by. Oh, do they have a info here that I can see? So, Zero CTF was a. Let's get rid of this real quick. Zero CTF was a Jeopardy CTF run by Oops and Tencent, I believe. Doesn't say that here. Maybe under partner? Well, I don't know where I read that, but as far as I'm aware, it was run by Oops, which is one of the CTF teams that plays quite a bit and does quite well. If we go on CTF time, I believe they ended up pretty well last year. They play a lot of CTF, although sometimes they play as Bloop, I believe. But in any case, they put on Zero CTF last weekend, and I played in it for most of the weekend along with a group of people that I've been playing with. And I thought it was a ton of fun. So the CTF was extremely hard. I think that's, from most of the comments that I've seen people have about it, one of the big comments everybody seems to have is that it was hard. So they had several challenges. I wonder, can I still log in here and see them? So as you can see, I've been playing as NASA Rejects recently. Do we still have the tasks here? Yes, we do. So here are the challenges they had. They had quite a few pwnables. They had a good web category that was apparently quite difficult. They had some reversing challenges, some miscellaneous challenges, some crypto challenges. Most of what I took a look at, though, were some of the pwnables. So the challenges that I took a look at were Baby Heap, which was a heap exploitation challenge, and I'll talk about it a little bit in a second here. Diet Hard, which was... okay. I just did this yesterday, and now I can't remember what I did. We'll get to that. And then EasyPrintf, all of which were exploitation challenges. So I'm going to go through a few of these real quick right now, talk about it. But in general, like I said, I thought the CTF was a ton of fun. Those are the three challenges that I actually managed to solve. I also took a little bit of a look at, very brief look at Note with one of my team members who was working on it. And I looked at Char for a while. So Char was a ROP challenge. Basically, you had you had to create a ROP chain that would pass a filter for all the bytes in the ROP chain. So it was quite interesting. I spent probably 2 or 3 hours on it. I was trying to do a couple different techniques to do an exec VE of system or an exec VE of binsh or system binsh. Basically trying to do math on registers in ROP and get it all to work. And at least what I was trying to do, I think it was failing because they had just immapped in libc and hadn't loaded it completely because it was crashing in the system call or the exec VE call. I didn't look into it too much because I was playing CTF and trying to get things done, but my halfway educated guess is that it was basically that the data section wasn't getting loaded properly, so it was not having values it was expecting to load in for the environment or something. And after I spent a while working on that, I eventually said, you know what? I'm going to hand this off. I'm going to go look at some other challenges. One of the other challenges I took a look at was integrity. That was a crypto challenge. I know in the IRC, and I can't remember who it was now, but one of the other groups posted their write-up on all the crypto challenges. I would recommend it if you're interested in crypto. Go take a look at it. The write-ups looked really good about it. But enough about the challenges that I didn't solve. How about the challenges that I did solve? So I posted some write-ups. Write-up is a very loose term here. Of the challenges I did work on. Well, I did solve. So Diet Hard. Diet Hard was using some sort of a non-DL-malloc allocator. I don't actually know what the allocator they were using was. It's possible that this is something that's common out there and it is everywhere, and I just haven't seen it before. Or it might have been something that they wrote themselves. In any case, there was some special handling for the code around if you're... So you were basically able to send it... Here, let's take a look, actually. So in Diet Hard, I named it Die Hard here and completely typoed it. But in Diet Hard, you're able to add a message. I'm going to add a few bytes here. I'm going to send some bytes. And I can delete a message. That's it. Those are the only options I have are to add and delete a message. And basically, the challenge was there was this custom allocator, which, well, there was this non-DL-malloc allocator. And in the code, there was some special handling around if an allocation was above 2016 bytes, but below, I'm trying to remember what it was off the top of my head, maybe 2048 or 2100. It was some number of bytes larger than 2016. And while I was investigating that, and I basically just loaded up the binary in GDB, poked at it a little bit, was playing with it, I noticed that if I had a 2015 byte allocation, it would return the same value for the pointer, the allocator would. Oh, what is going on here? Oh, there we go. Hopefully you guys actually heard that. My computer decided that it didn't like what I was doing and had to catch up, so hopefully you guys didn't miss anything important. If you did, send me a message and I will repeat myself. But anyway, in Diet Hard, basically, I noticed that the allocator would sometimes return the same pointer twice. And basically, if it was around that 2015 boundary, it would return the same pointer twice. So to solve the challenge, the way that I did it was I just took advantage of that. So I send in two allocations of that 2015, and the third one will overlap with the second one, I believe. So I built this buffer, which is to overlay the struct that's there. And I send this in, I put in a second one, I then go to delete it, and when you delete it, if you notice here, it prints out the contents. So I'd actually bashed the pointer of what it was going to dump to us, and I'd bashed it with this right here. I believe that's a GOT address. Yeah, it looks like it's a printf GOT address. And I just leaked that back to me. I got an address. I did it again. And I used the bespoke gadget. And so the bespoke gadget is basically a specific gadget. It's a ROP gadget in the 64-bit libc, which if you can get program control at that address, it pops a shell for you. And so I just did that again. I went with it. Worked out great. So it was Diet Hard. Once I actually got that part of the challenge, worked out pretty easily. And then I also took a look at Baby Heap, which was a heap exploitation challenge. Again, relatively straightforward. If you want to take a look at what it actually looked like. Baby Heap. You come in here, you execute it, I can allocate, I can fill it, I can free it, and I can dump it. Pretty straightforward, right? And if you go into the binary and actually take a look at it, the trick is that I can write as much data into this thing as I want. I make an allocation of a size that I want. It has to be less than, I think, 1,000 hex bytes. And then I can write as many bytes into this thing as I want to, though. So the way that I ended up solving it was I used, I always mix up the names here. There's fast bins, small bins, and large bins, I think are what dlmalloc calls them. So I create a couple small bins. I then overflow from one of the small bins into the next one to resize that second one as if so that it overlaps entirely with the third one. I free the second one. So now now dlmalloc thinks that there's space for 2 new allocations to be made. So right here we have I and j, and when those get allocated, they actually overlap. So j is allocated in the same space as g was. And I'm allocating a third pointer there just to help with any, I'm blanking on the word now, consolidation of free blocks in the future. That way they won't mess any of that up. So then I free j, I free k to force all the pointers to get flushed, because when I free k is at the top of the heap. So when I free that, a consolidation pass goes through because it tries to consolidate everything down. And after I do that, I dump out G to me. G was this overlapping buffer. And so what that does to me is that's going to print out the pointers that the free block has in it. Basically, now I have a address in main arena that is in the libc data section. So now I know where libc is in memory. And because of how the protections in the binary are set up, that's all that I know is in this binary. I don't have addresses for anything else except for the libc data section and libc itself, but that doesn't help me all that much right now. So basically what I do here is I'm going to use the fast bins now to set up a allocation in the middle of that data section. Basically what I did here was I opened up, I believe the first time I did this, I opened it in GDB, and I just searched bytes in memory. I did a find, start of address, end of address, the bytes I was looking for, and that's just, I went through one at a time. OX11, OX10, OX20, OX21, and so on for all the possible sizes of the fast bin size, because for the fast bin trick to work, I need to have in memory someplace a quad word, which is the size of the fast bin that I've overwritten the next free pointer in. Basically, all that means is I need to find someplace in the libc data section where one of those valid sizes for a fast bin is. And the way that I did it the first time was I just searched through it in GDB. That worked fine. I tried it on the game box, failed terribly. So I went back, I worked through this a little bit more, and the way that I ended up solving it the second time was I actually just opened up their libc in IDA and scrolled through the data section looking for that sequence of bytes that I needed. A 30 hex, a 31 hex, a 40 hex, a 41 hex, and so on. And I believe what I ended up finding was a 40 hex that was just in the middle of something else. I don't have the slightest clue what this symbol is or what it's supposed to be doing. It is actually not 40 hex. It's actually 4000 hex, and I'm actually going 1 byte over into it so that it works out the right way. In any case, I found this in the data section. You can see here on my machine, for my libc, I believe it was OX917 minus the memline hook that I was using as the value in the libc data section that I actually knew where it was. On their libc, it was 417 hex. So yeah. And then after that, it's pretty straightforward, right? I figure out where that is. I come in here. I'm going to set up this buff. And basically what I'm doing here is the start here is just to go from the start of this A record until I get to the start of where the next record would be. that I care about. And I basically just found this through trial and error. I did a really big cyclic there, and then I threw it far enough in that it would segfault on me when it went to dereference that pointer, and I just backed off from there. So what I did is I'm basically building here a fake free block. So I have the previous size. I don't actually know if I need to reset this to 0 or not, but it was easy enough to do, so I just did it. Then the size of the current free block, and finally a pointer for the next free block in the free list for the fast bins. And I just dump that into A, which is this allocation here. It's going to overflow all the way through A, all the way through B, and then it's actually going to set C, that free pointer in it. And then it's pretty straightforward. I allocate one, and I allocate a second one. I don't actually need to do this filling it with /binsh. Originally, I had been trying to make it work with system, and eventually I decided, you know what, I don't care enough to actually do that. No. What I was doing here was I was actually going to use the free hook and do it with system, and eventually I decided, you know what, that's too complicated. Instead, what I ended up doing was I just used this bespoke gadget, and voila. I dump in a ton of bytes. I smash all over the libc data section, and then when I send these 2 ones, that's going to be trigger an allocation of 1 byte, and I've actually bashed the malloc hook in the libc data section. So when it goes to make that 1 byte allocation, pops a shell for me. So that was Baby Heap. And then the final challenge that I worked on and actually solved, that was EasyPrintf. And EasyPrintf, I thought, was a great challenge. It was relatively straightforward. So the way the challenge works is we come in here. I'm sorry, it's easiest printf is what it was actually called. And I run it, and it asks me, there's a sleep in here that I'm not actually showing. It asks me what address I want. I give it a valid address. This is segfaulting, but I give it a valid address. What did I give it in my exploit? I believe I just gave it like a God address, right? Yeah. It had to be in decimal. I think it had to be in decimal. So I run it. I dump this address in. What address do I want? It calls goodbye, and the next thing it does is it's going to let me send in a few bytes, and it's actually going to pass it to the format string argument in printf. So basically what you need to do was I get a single read of any address I want, and then I get a format string bug. However, immediately after this in the binary, and let's actually pull this up real quick. So I can come in here and take a look at it. Come on. There we go. I come in here. One thing to note here is that I actually took a look at note in this a little bit, just because it handled loading up some of the KO a little bit better than IDA did. Other than that, I didn't use Binary Ninja much during this competition. IDA did pretty well on almost everything I tried to look at. So anyway, so basically looking at the binary here, pretty straightforward. They read in dev random, they go through, they do this do read, which was that what address do I want to read? They're going to scanf it, then they're going to just printf out whatever address I asked it for, and then they call leave. Leave, also pretty simple. They do this memset, they do a puts of goodbye, and then they come in here. And what they're doing here is they're reading in as many bytes as I want. I believe it's as many bytes as I want. And they're going to pass that, it can't be as many bytes as I want because it's going to, yeah, it's only 9 E bytes, so that there's not a buffer overflow there too. They're just going to pass it to printf and then immediately call exit. So that's a little trickier than it sounds. Normally you'd think, oh, I've got this format string specifier. I'm going to do the super standard stuff with a format specifier. I'm just going to, I'm going to use %n. I'm going to write into some place. I'm going to use that to get code execution somehow. The problem is that, one, this binary is compiled with all the protections. It's full rel-row, which means I can't just bash a got pointer. The canary's there, it's got nx, pi is off, but everything else is turned on. So what am I going to do here? Because it's calling exit, actually, while I go in here, one thing that I found here is that because there were so many possible ways to land this, I found a whole bunch of different solutions in the IRC. Like, I was asking around in the IRC after the fact, and I ended up finding several different ways that people ended up solving this after the fact. And that's something I really like about this challenge, is that I had one solution, which ended up being the same solution as, and I hope I don't butcher the name, Ginvel from Dragon Sector did. But there were also a ton of other solutions that people had for it. So one thing that Ginvel has here that is great is here's a list of all the things that don't work. So because they're calling exit, the destructors table, which is where you can typically get in for a full rel or binary. I'm going to throw something in the destructors table, and then that's going to get called when everything gets blown away. Or at exit, it's interesting that he notes here that there's the standard outs function table. One of the people in the IRC mentioned that they did successfully solve it using this exact same technique, I believe by doing exactly this, changing the address of the vector table. But yeah, there's a ton of things that just didn't work. So the way that the two of us ended up solving it was we actually went in and we blew away the malloc hook. So one thing that doesn't come up very often, but is something that I've had on my mind for a while now, is that printf, under certain very specific situations, will call malloc. And so that raises the question, why exactly would it call malloc? And the answer is there's actually several different ways to get into this code, but and several different ways that you end up here. But the short version is it will call malloc if the format specifier you are passing it could require more characters than it currently has space for, which according to Ginvel is 16 bits worth, however that math works out. 65536, I think. So the way that we ended up solving it was actually coming in here and going, that's not what I wanted. I wanted the actual exploit code here. Coming in here, running it, and setting up. So the way that I ended up doing it here is the % size dot and then an X. And what I end up doing here is essentially it's going to make an allocation that is a address that I know the location of in the data section for the. So let's start over here. Let's run through this exploit real quick, because I know what I just said was super confusing. So I open it up here. I find out here's the address of the GOT, and I print it out to me from that info leak intentionally in the binary. After that, I need to build the buffer that I'm going to use here. So I just going to go through real simple here, and I'm going to build up a format string and a list of pointers. So this right here is basically, I played with a couple different ways of doing this. Basically what I'm doing here is I'm using %n, or specifically the %, I don't remember what they call it exactly. It's the indexed argument. Because you can do % integer value $n or $hn, and instead of popping the next value off, it will be that indexed argument. So I would come in here and I want I want the 7th argument, and then the 8th argument, and the 9th argument, for as long as it takes to get all of the bin sh in there. And basically I'm building this all up because I tried several different ways here. Like I wanted to be able to do bin sh, I wanted to do bin ls, bin echo, because during some of my testing, I was failing and I wasn't quite sure why. So I put this together basically just looping through. I have a list of the format specifiers, and I have a list of the pointers that I'm going to write those format specifiers to. In this case, so I built this up of just in the data section someplace. I don't actually remember what this address is. I think I just picked a value after everything else useful, so I knew I wasn't going to blow away anything else. I build it up, and then I'm going to overwrite the malloc hook. And specifically, I'm overwriting it with system. And the reason this is important is because if you take a look at the binary here, this is a 32-bit binary. So even though we had that bespoke gadget that I mentioned before, that doesn't exist on a 32-bit libc. So there's not some magic gadget that I can just call and get a shell. Instead, I have to actually do system bin sh or something equivalent to get a shell. So what I'm doing here is I'm going to modify system, or I'm going to modify the malloc hook to point at system, so that when it calls malloc, instead, well, the first thing malloc does is it's going to call system with the same argument that was passed to malloc. So I come in here. One thing to note is that because of how things are set up in their libc, I can't actually write directly to the malloc hook in 2 passes. I have to take 3 because if I do malloc hook, I believe that address was 0. It ended in a 08, or it ended in a 08. So the second write would then be 0a, which is a new line and terminates the read function. So I had to do 1 single byte write, 1 2-byte write, and then 1 more single byte write to actually overwrite the malloc hook with anything I want. So I do that. I set up the format specifier for that. I then build my complete format string. So that I've taken the list of pointers and then the format specifier after that, and I put it all together and I write it in there. And basically what that does is it just sets it up. I write /bin sh into the data section of my binary. And then I overwrite the malloc hook with system. And then I'm using this specifier here, the percent, in this case, I was doing percent number $, length, dot, and then an X. In this case, I was doing that just to do some testing. I could have skipped out on that part right there. That part right there. There's no reason I actually needed to give it anything as the specifier. Like I didn't need an argument there. I just used it as testing so I'd see the value. The important part here is the %d dot here. And what I'm doing here is I'm saying when you go to malloc this, the length is going to be 32 less than the address that we actually wrote bin sh to. And then end result is that it ends up calling system with bin sh and it pops me a shell. Yeah, pretty straightforward, right? So let's actually take a look at this. So I'm going to, in GDB, just pull this up, because one of the things that I really like about this challenge, and I thought was really great about it, is that basically the challenge amounted to you can write anywhere in the libc data section you want, or in the binary that you want. But immediately after you do that, it's going to call exit on you. So how do you actually do anything there? Like, what do you do? And there's a whole bunch of techniques that are pretty standard for stuff, but most of them fail because you're calling exit immediately, and it's full railroad, so you can't actually do much there. So, like I said, there's a ton of cool solutions people came up with. I've put them in the README on my write-ups here. For example, I think this is Loxa. I hope I'm pronouncing that right. The technique here, oh no, it was in the IRC and I don't remember what, let's see here. Which one was this? Oh, so I believe Loxa here is, messing with that standard out. It's exactly the technique that Ginvale talked about here, about trying to change the address of the vtable for standard out. And what this person is doing is basically they're setting up a new vtable for standard out, so that when it goes to print data out to the screen, instead of doing that, it's going to call system with some sort of arguments. The binsh that it would be to print. So basically, it's going to try and print binsh out to the standard out, but instead they've bashed the standard out here. And if we want to see this, so if I come in here, they're using they're using ELF out of pwnTools. For challenges like this, it's really great. If you're not using it, you really should be. Basically, what you're able to do is you use this ELF right here. It takes in an ELF and it parses it, and then you're able to do things like I'm going to set. Okay, so in this case, they've calculated a libc base, and then the libc symbols and then a symbol name will just return what the offset into libc is. Another option that I like to do is you can actually set the address for libc. So I calculate out what that address is, and I actually set the libc address to be what the base would be. So I leaked out the address of printf in libc here, and I subtract what the offset into libc printf is at, and I set that to the address here. That instead, when I come down here, I don't have to add that base anymore. They've handled it all for you. But yeah, this is from pwnTools. It's great for a lot of this exploitation stuff. It lets you do super simple stuff. Otherwise, I'd have to be pulling up my dissembler, I'd pull up IDA or Binary Ninja or Redair or Popper or whatever it is you use, calculate all these things out, then probably change it, because I have a local version and I have the remote one that's actually running out there. They've got different offsets, so I'd have to do that all again with theirs. It's a huge pain. Instead, I just load a different libc. Super simple. But yeah, so they do this. They bash this, and if we actually take a look at it, so I'm going to run it real quick. We can come in here and we can say, oh, sorry, I messed that up. What exactly does that look like? So this is that symbol in the libc data section. Basically, this is a list of pointers. So this is the vector table for the pointers that they're going to bash. If we come in here, what this person did was they calculated out what it is. They calculated the system here. And then they basically set up a... What's going on? Oh, sorry, I got a message on one of the other screens here. They basically just set it up to call system with the rest of that when they would go do the rest of their output. So pretty straightforward, works great. This. I haven't actually looked at this in a ton of detail yet. I just collected up some of these last night when I saw them because these different techniques. So bashing that vtable, I think, is a great technique. And it's one that keeping in the back of my mind, because at some point in the future, all the techniques that I like to use are going to break for some reason. So knowing that I can do things like bash this structure are going to be super useful. I don't know what this function here is, though. Is this something that's part of pwnTools? It is. I've never actually tried any of this stuff. So apparently, pwnTools has stuff specifically for format string bugs. Huh. That is amazing. I had no idea this was a thing. Wow. So now you know. Apparently, pwnTools does a whole bunch of this stuff that I did manually for you automatically. That is great. I am so glad I know about that now. But one of the other things that I saw somebody talk about in the IRC that I thought was just amazing is that apparently you can set up a new format specifier as an extension. And what they did was they went into the data section here, and they actually set it up so that there would be a new format specifier of whatever they wanted. I think they mentioned the IRC that it was a %K. And they basically just set that up to pop a shell for them. Unfortunately, I don't see how this works here. They just mentioned that this is how they solved it. I didn't see a full write-up on it. My guess is that if I really wanted to right now, we could dig through this and figure it out. But there's another, like that's the method they use. So basically they overwrote whatever structures this extension uses. Actually, can I see this here? So they have a print widget that accepts some arguments. You apparently register a printf function. You register a W. So if I was going to do this, the approach that I'd take is, and you know, I actually knew that this was a thing ahead of time. I basically compile this program right here and then step through what the register printf function is doing. Because obviously it's modifying things in the libc data section to add in how to handle this. So we'd have to go through and we dig through it. And actually, you know what? Let's take a look here. So I want to break on register printf function. Right? Sure. I want to register a printf function. I then want to call register printf function, and I want to use W. I'm specifying 2 arguments, right? Let's use system and printf. I have no idea what these are. Nope. What? Oh. So there's an alarm in here that I haven't replaced. No, I don't want a core file. I want to run, break in. Let's try this again. So I'm going to, so what just happened there, if you didn't follow that, is there's a sig alarm, or there's an alarm in the binary, and I actually hit the alarm because I had it broken in for so long. So let's do this again real quick. I want to call it then. So I'm now in this thing, and I can go in here and I can say, okay, what exactly are you supposed to be doing? Sorry. Like I just said, this is a 32-bit binary, so I can't just do stuff. So apparently I don't have my GDB set up properly here. So they're going to call another function. This looks complicated. What about in here? So this is vprintf. Are you in here? Register. Nope. So what I've got here is, I don't actually know what this is. Like I just Googled the printf source code. And it pulls up sourceware. So what is this? Sure, let's take a look at this. They changed. Don't. Here we go. We're registering a printf modifier. They're going to mess with some structures in here. There's apparently a printf modifier table. It's a symbol that I can use. So, nope. That's unfortunate. Well, in any case, we can go through here, we can dig through it. This is apparently another technique that we could have. We could register a new specifier and set it up to call system sh if we wanted to then. Finally, there was one other technique that I heard, which was from, again, I'm going to butcher a name here, sorry, Uafio or Uafio. Not sure which exactly is the right pronunciation here. But the short version of it is that he used the kernel Vsyscall. And the kernel Vsyscall, let's see what Google has to say about it. What is kernel Vsyscall? Sure, Stack Overflow, why don't you tell me? Kernel Vsyscall is the method used by linuxgate.so, part of the Linux kernel, to make a system call using the fastest available method, preferably the sysenter instruction. This is properly explained here at another link. So, what's going on here? So there is a symbol in here someplace. Let's go to the next call to it. You can find out if your machine is using it by disassembling what is there. This was not quite as useful as I thought it was. Let's try the next version. When you make a system call, like reading from a file, talking to hardware, writing to sockets, you're actually creating an interrupt. The system then handles the interrupt in kernel mode, and your call returns with a result. Most of the time, it's unusual for you to have a lot of threads in Vsyscall, unless you're making blocking calls, in which case it's expected. Oh, this is the exact same Stack Overflow. Okay, let's see what GDB has to say about it. What does GDB have to say about it? Apparently, this is a thing here that looks like a string to me. It is not a string. That is, in fact, a program. So, what exactly is going on here? So they're going to push and they're going to ret. What did UFO actually do here? So, I've got a script here on my other screen, which is basically setting up a... Oh no, don't do this to me. This is unfortunate. I think I'm getting to the point where I need to rebuild the current CTF machine that I'm using, which is what I'm on here. I'm not sure what exactly I've done to it right now, but it will periodically lock up on me, which indicates that I've broken something horribly. My guess is that I've got something that every, so often is going into a loop and never returning. I don't know if I broke something inside the VM, outside the VM, like if it's a driver someplace, if it's what. Or maybe I've just got, malware someplace, which is, that was uploading, all of my search history off to who knows who. Who knows what it is. But I need to get around to actually blowing this all away and getting that all fixed. I've been putting it off because every weekend there's been a decent CTF to play in instead. Why would I fix my problems when I can just play CTF instead? But looking at the UFO stuff here, it looks like... what are we doing? We are setting up basically the same thing, setting up a structure here, and it looks like he's actually getting to write some ROP chain stuff into it. So that's the short version of this. Like I said earlier, looks like I'm actually going to end a little bit earlier. Not sure if you're going to hear it or not. My throat's been bothering me a little bit, not feeling real great. But like I said earlier, I really like these kind of challenges. So this was a relatively simple challenge that was relatively straightforward. You take a look at this, I open it up, I say, okay, I've got a pointer leak. Okay, I've got a format string vulnerability here. Now what? Where there's a ton of different solutions that different people came up with. And going through and looking at all these, now I know a lot more about what can I do. So because I was able to go through, I took a look at a lot of these things, and I got all this new information about different ways people can do exploitation. It's super useful to have that information because, again, maybe it's not next week, maybe it's not the week after, but maybe a year from now, I'm looking at another pwnable, and this time, for whatever reason, I don't know, for that reason, the only way that I'm going to get exploitation is if I can create a new format string specifier. I don't know if that's ever going to happen, but that's a possibility that's going to come up at some point. And having in the back of my mind that that's a thing that you can do is super useful for future exploitation challenges. Like, maybe the situation's going to be something like Baby Heap, where I'm only going to be able to get a write into certain addresses into the data section. And because of how that's set up, I'm going to be digging through structures until I find one that I recognize, usually, and taking that and trying to turn it into something useful. So just to recap that real quick, the techniques here that I saw used were this kernel Vsyscall thing, the printf specifier thing, the vtable for standard out, and then just using the malloc hook and writing using a format specifier that triggered a malloc. As far as I know, those are the only 4 solutions that I saw. It's entirely possible there are other solutions out there that I just haven't seen. If you have one that you solved it with, I'd love to hear about it. Like I said, having all of these cool tricks that you can do in the libc data section, I just think are really fascinating. They're interesting things about how the programs you write work that most people don't even think about. One of the things that I came across on accident quite a while ago while I was working on a challenge that completely blew my mind is that the standard in and standard out are actually shared across processes. It makes sense if I have a process and I pipe into another process, how they talk to each other is shared. And the reason that's important is because if you mess with standard in or standard out in a process, and its in and out is shared with another process, and that starts up a third thing, you can actually tamper with what's going on. And the actual specifics of that don't matter. The effect, though, this was, oh man, I don't even remember what this was. This was quite a while back. I was testing one of the heap exploitation techniques. So one of the heap exploitation techniques that's come up in the past, we go reference how to heap because it's great. Thanks, Shellfish. Is, what do they call it? The unsorted bin attack, which is, there's a trick here that turns out it was actually in 0CTF last year that this came up. There's a trick here that lets you write the size or the point. It lets you write a value to any address you want. It's not I believe it's a heap pointer that you can write anywhere you want in memory. That isn't particularly useful. Like if there's nothing, like what are you going to do with that? And when I was solving this challenge last year, I was going through and I was saying, okay, I have this, and I put together and I don't have this anymore, but I put together basically just a long shell script which would try every single possible address in the libc data section, and then some very simple logic to classify, did you crash? If you crashed, how did you crash? And is the output what I expect it to be? And then I just ran through all the addresses like that. One of the things that ended up happening that completely blew my mind and I didn't realize was going to happen at all was when I got to those standard in and out pointers and I messed with them, what I actually ended up getting was the next attempt, or 2 attempts on, because of how the actual file structure works. If you care, you can look it up later. What I ended up getting was a huge chunk of the libc data section actually sent back to me as output. Basically what was happening was that I was tampering with where the standard out thought it was in terms of buffering. So when it went to finish buffering output to me in the next process, it actually just spewed out all sorts of data that it shouldn't have been. And yeah, not entirely sure where I was going with this story, except that I really like to find all these cool tricks that when you have some sort of memory corruption in the parts of a program that nobody ever really thinks about, what exactly can you do? In this case, the answer is almost certainly, if it's in a CTF, get code execution. But yeah, one last thing that I would like to do before I sign off a little bit early. So UFO mentioned in his baby heap write-up here a tool that he was using, which I thought was pretty cool, which is talking about these bespoke gadgets. Who is this by? This is David942J wrote this, which is basically trying to find all of these automatically. Ooh, apparently there's... So I have not played with this previously, but this will apparently dump out all of the different gadgets that you have that would do that. And basically, like I said, there's several of these that exist. Apparently, this has a ton of actually really cool features. One of the things that's really important about these gadgets is that the certain values are required to be null. They don't actually have to be null. They have to be a valid pointer. They have to be a valid argv. So it needs to, if it is null, it works, or it needs to be a pointer to a list of valid pointers that is null terminated. So this is saying it's null because it's an easy way to remember it. It's not strictly true. There are other things it could be. For example, this is describing it right here. The RSP plus 70 hex doesn't have to be null. It can be null, or it can point to something that is null. Or point to something that's a valid pointer and is followed by something that is null, and so on. So here are all these gadgets. Apparently, this is finding them in 32-bit libcs too, that I did not know was a thing. I was under the impression that it only worked with the 64-bit ones, but at least according to this, it does in fact exist for at least some 32-bit libcs. And then there's some discussion here about how to use it in a exploit directly, or using whatever the libc database is that their backend is. So this is pretty cool. I'm probably gonna pull it down, play with it a little bit. Trying to pull up these bespoke gadgets in IDA or Binary Ninja is pretty straightforward and simple, and that's what I usually do. But having all of this printed out like this, probably a little bit faster, and it's probably something that I'll work into some of my workflow. I know I've got a couple, one-off scripts to find these, but yeah, that's about all that I have today. Like I said, my throat's bothering me a little bit, so I'm not gonna talk for hours on end tonight. If anybody has any questions, let me know. Feel free to send me a message. You can tweet at me. You can message me on GitHub, IRC, YouTube. I'm on several different Slacks. Basically, however you want to get a hold of me, feel free to ask me questions, comments, thoughts, generally whatever it is that you've got on your mind. I'm interested in hearing it, especially if it has to do with CTF stuff. One thing that is important that I have not mentioned yet is that this weekend, like so many weekends, there's another CTF. There's actually two CTFs this weekend. The first, and at least in my opinion, the more important one, is VolgaCTF. So VolgaCTF, I remember playing it last year. It's run by a university group, I believe. It should be okay. One thing that I do remember from last year that was quite interesting is that instead of having an IRC for discussion, they used Telegram. So yeah, we'll see how that goes. Apparently they're doing the same thing again this year. There's also a couple of other events going on. So there's Insomnihack, which is in person, which is probably pretty good. And if you're in the Geneva area, it's probably well worth going and playing in, or the conference. This is associated with the Insomnihack conference in Geneva. I don't know anything at all about the conference. I do know that the CTF, at least the calls for it, which were held, the teaser that was held a month ago, 2 months ago, is a ton of fun. The stuff that 0 Day Sober puts on has generally been pretty good. I think I've played in the teaser for the past 2 years. It's generally been a lot of fun. It's usually pretty short but fun. So again, if you're in the area, I'd probably go check it out. There's also 2 other events going on that weekend. There's the White Hat Challenge, and I don't know what double S1405 CTF is. This is popped up since the last time I was here. Apparently it is a Korean group, or it's a Korean CTF with some prizes and stuff. Yeah, there's several events going on. Most of these are what I would consider smaller CTFs. The one I'm probably going to play with is VolgaCTF. I might take a look at the White Hat if I get bored, but personally, I'm not going to spend a ton of time this weekend playing. I'm not going to spend all weekend like I did for 0 CTF, just because later on in April, there's a ton of really good CTFs every single weekend. Starting at the end of March, there's going to be the Nuit du Hack Quals. The next weekend is going to be the ACES CTF. The following weekend is BCTF, which is run by Blue Lotus, which is the other part of Bloop. Them and Oops get together sometimes to play at events. And then after BCTF is going to be Plaid CTF. And then finally, the last weekend in April is going to be DEF CON Quals. So all of April is going to be tons of CTF stuff and should be a ton of fun. Oh, hi, Live Overflow. It's apparently messaging me in the chat. So, like I said, there's going to be a ton of cool CTF in the next couple weeks, or next month and a half or so. This weekend, the one that I'm probably going to at least try a few challenges out of is VolgaCTF, but there's also double S1405 and White Hat Challenge, which I might take a brief look at. We'll see. Oh, there's also Angstrom, because I can't read. Like this weekend, all of these events are going on. That's a lot of CTF this weekend. There's also PycoCTF coming up. That's if you are a current student, it's probably, if you're a current student or learning or anything, it's probably really great to take a look at this and give it a try. It's run by PPP. It's designed for high school students. These should be fairly simple challenges. I'm trying to see here. I remember last year talking to a number of people who went through last year's version of it, and apparently really well put together, a lot of fun. It takes place over a course of 2 weeks, so you've got plenty of time to give it a try. Definitely worth a look. That's going to be in that first part of April too. And that's pretty important because looking at the calendar for April, there's a ton of great looking CTFs. They're going to be really difficult. Like I said, DEF CON Quals is going to be there, Plaid CTF, BCTF. I expect all of those to be really good, but also really hard CTFs. So like BCTF and DEF CON Quals, I kind of expect to be about as difficult as 0 CTF was this past weekend. So if you're newer to playing CTF or you just prefer easier challenges, taking some time to look at PycoCTF instead might be a good way to spend your time. So anyway, that's about all that I have right now. I'm gonna sign off for the time being. Said, feel free to hit me up. Let me know if you have any questions or comments. Let me know if you think I should have done something differently or any cool techniques. One of the things that I really like about doing these events, doing these streams, is that I tend to learn a lot by talking through things. So today, I learned about this format string payload thing at Opponent Tools, which I am totally going to use in the future because holy crap, is that awesome. That is super useful. As you could see in my exploit for it, I was building this all by hand. I was putting everything together. Turns out all I needed to do was call a thing at Opponent Tools and it would just do it for me. So rather than dig through all the details here in front of you, I'm going to take a look at it later and probably try and work it into the stuff I do later. So thanks everybody for checking things out. I'll see everybody later. Bye.